pan and a jar to film this, but let's get right on into it.
A precipitation reaction is known as the formation of a solid from two aqueous solutions mixing to form an insoluble substance known as a precipitate.
When dealing with precipitation reactions, there are rules that need to be followed. Solubility charts are used to determine whether two solutions will react together to form a precipitate. Why don't we go ahead and look at some of those now? All right, so starting off, we've got our soluble ions. Starting off, we have nitrate with a charge of -1. We've got our group 1 elements such as lithium, sodium, potassium. They have a +1 charge. Then we've got our group 17 elements. Those would be like chlorine and bromine and all those ones. And then we've got sulfate, which has a charge of -2. Here we have our exceptions to this rule. All of these will form precipitates with all of its exceptions. Nitrate has no exceptions, so it will not form a precipitate with anything. Same with group 1, our lithium, potassium, sodium. But our group 17 will form precipitates with silver, lead, and mercury. The same with sulfate, it will also form precipitates with those three, as well as group 2, which is our elements like magnesium and beryllium and those sort of things. All right, on the flip side, we've got our insoluble ions, which will not be able to ionize or dissolve. We've got our silver, lead, mercury, and then we have our carbonate, phosphate, sulfide, which is an ion of sulfur, and hydroxide. And we've also got our exceptions to this rule as well. As we went over before, nitrate does not form a precipitate with anything, not even these three. Group 1 also does not form a precipitate with anything, including these ones. By using these solubility rules, we can see how precipitates are formed on a microscopic level. When we dive deeper, we can see that these aqueous solutions are composed of ionic compounds. An ionic compound is chemical compounds composed of ions held together by an ionic bond between cations and anions, which are positively and negatively charged ions. When the two aqueous solutions are mixed, a solid insoluble mass is formed.
In this reaction, we're taking potassium iodide and mixing it with lead nitrate. The reaction forms a precipitate of solid yellow lead iodide, and the leftover aqueous solution is potassium nitrate.
Here's a precipitation I did myself with 5 different solutions.
Overall, precipitation reactions are responsible for geological deposits, the rings around your bathtub, and some pretty cool chemical reactions.